Okay, so now we're going to look at the standard deviation and the variance. So the standard deviation is a measure of how spread out our data set is. It's the average distance that the data values are from the mean. So we have two different formulas, one for if we're looking at data from a sample. The second one is if we're looking at the data coming from a population. The sample standard deviation formula is the square root of the sum of each x value minus the mean squared divided by the sample size minus 1. The population standard deviation is the square root of the sum of each x value minus the population mean mu squared divided by the population size n. The variance is simply the standard deviation squared. The sample variance is notated as s squared because it is the sample standard deviation s squared, and the population variance is notated as sigma squared. This little funky looking O is called sigma. Let me write that down. This guy, I'm going to write it down over here. This guy is called sigma. So we're going to do a small example of how to calculate the sample standard deviation and the sample variance. We're going to focus just on the sample. We're not typically going to see a lot of data for the population, so we're not going to need to calculate the population standard deviation very often. We might be presented with it, but we're not going to be calculating it. So here I have a data set. It's a very small data set. And I'm actually going to do this by kind of setting it up in a table. So the first thing I'm going to do, I'm going to create a column, and I'm going to list out my data values. They do not have to be listed in order, they just have to be listed. Then my second column is going to be the sample mean for these values. So remember, the sample mean is found by adding the values together and dividing by the number of data values. So I have a sample mean of 74. And it's the same sample mean, so I'm going to write that all the way down, and we'll see why here in a second. So now if I look at my formula for the sample standard deviation, underneath the square root, it says that we're going to sum x minus x bar squared. So what I'm going to do in my table is I'm going to make a column for x minus x bar. This is called the deviation. How far away is the data value from the mean? So I'm going to go ahead and switch up my color right now. So this is going to be 63 minus 74, which I believe is negative 11, but I'm going to double check. It is. So the data value 63 is 11 numbers below the average of 74. So then I'm going to do this for the next data value. 88 minus 74 is 14. 77 minus 74 is 3. And 68 minus 74 is, I believe, negative 6, but again, I'm going to double check. Yes, it is. So these are my deviations, how far each value is from the mean. So then the next thing we're going to do is we're going to square each of these deviations. So I already found the x minus x bar, so now I'm going to square each of those. So the first one is negative 11. When you're squaring a negative number in your calculator, you have two options. You can either ignore the negative or make sure that you type it in parentheses exactly how I have written it. Otherwise, you're going to get a negative answer. and a number squared, positive or negative, is always positive. So all of these numbers that I get here should be positive. So I'm going to go ahead and square each of the answers that I got for the previous column. And that guy is positive 36. So at this point, I have done this much of this formula. I have found x minus x bar squared. So the next thing I want to do is I want to sum or add up all of those values. So I'm going to take the sum of this last column. So 121 plus 196 plus 9 plus 36. And I get 362. So coming back up to the formula, now I've done this piece as well. So the next step is to take that sum and divide it by the sample size minus 1. So our sum is 362. Our sample size is 4, and 4 minus 1 is 3. So we're going to take 362 and we're going to divide that by 3. You want to make sure that you take the 1 away from the sample size before you divide. Do not divide and then subtract 1. That would be incorrect. So now I get 120.666. It repeats on forever and ever and ever. We don't want to round this number until we get to the very end. So when we go on to the next step, we're going to type in a bunch of 6s and then a 7 at the end. So we've done everything underneath the square root at this point. So the last thing we're going to do to find this standard deviation is we're going to take the square root of 120. So I'm going to square root 120.66, lots of 6s, and then a 7 at the end. And we get 10.985. You want to give at least 2 to 3 decimals, maybe more depending on how many decimals you had in the original data. If your original data is giving you more than 2 decimals, then you should be giving at least that many number of decimals in your standard deviation. So this is the standard deviation. This is telling us how spread out our data is. And there's another video that will kind of talk more about that interpretation. This one is more just on the calculation of the standard deviation. But we're not done yet. We also want to calculate the variance. So the variance, coming back up, is the standard deviation squared. So I'm going to take the standard deviation, 10.985, and I'm going to square it. And I get 120.67, which should look pretty familiar, because when we took the square root of that 120.666 repeating, the opposite of the square root is to square. So this number is your variance. This number is also my variance. They're pretty much the same number. And we notate that with a little s squared. The standard deviation is just a little s. So that is the calculation of the standard deviation and the variance.